Hello, this is David Klee from HeroFlux Technologies. Today, we're going to talk about what to do with Windows Perfmon information after you've already collected it. If you've not already taken a good look at how to set up Windows Perfmon for ongoing performance metric collection, click on the link in the description below to get a good demo of how and why to set up Windows Perfmon information on all of your important servers. Windows Perfmon information contains an absolute wealth of critical insight into what your systems are doing around the clock. Perfmon does a great job of collecting this information, but does a terrible job of giving this information to you in a format that you can do something with. In my line of work, having this raw information to help understand performance trends or pinpoint symptoms of underlying performance problems is absolutely critical. So we wrote a Powershell script that allows people to take this information and import it into a Microsoft SQL Server database table so that you can use any of your favorite analytics tools to mine this data for both key metrics related to performance as well as ongoing performance trends for this data when analyzed over time. Let's get started. Okay, now we want to go grab the Powershell script. If you go out to github.com/heroflux/blg to SQL, you'll find not only the PowerShell script for how to do the import, but a handful of informational query samples that you can use to actually go set this up, as well as a database schema that we're going to use to set this up. You'll notice there's two schema files in there. One is for SQL Server 2016 and above, and the other is for previous versions other than SQL Server 2016. All you have to do, download the code and save it to a location on one of your machines, preferably not directly on your SQL Server, but something that has access to it. Okay, the very first thing that we need to do is to create a placeholder for where we're going to drop all of this data. Now, you may have a utility database or a stats database or some sort of working bucket for you to drop this into, but if you don't, we're just going to go ahead and create a database over here. So whatever your preferred method through the front end or T-SQL or however you want to do it, I'm just going to call this Perfmon Importer or Perfmon Import. Now, I'm a little picky. One of the things I really like to do is to auto-create incremental stats, auto-update stats asynchronously. I'll turn on Query Optimizer fixes, I'll allow snapshot isolation, and I will force isReadCommitted_snapshot on. Now for this particular server, one of the things I am going to do is to turn on delayed durability. If you're not familiar with it, stay tuned for a future video. It's actually incredibly helpful for use cases like this, where you have the actual data and the operation is restartable or retryable. This can actually help speed things up. So in this case, we're going to do allowed. Now out on the GitHub page are a couple of functions and a simple little table for us to import into. So what I'm going to do is I'm going to take that script and I am going to import this into the new Perfmon import database that we just created. And you'll notice it's just a couple of functions that help you round dates to a particular certain time span, as well as our Perfmon import table. And you can see it's pretty simple. Got an identity value, server name, timestamp, counter set, counter name, counter instance, and our value. And now because this is SQL Server 2016 Service Pack 2 or above, in this case this is a 2019 instance, I'm going to use a clustered column store index instead of the usual primary key clustered index combo. There we go. Nice and simple. Our bucket is now created. Now that you have the file downloaded, go ahead and open up the blg to SQL.ps1 file. This is our main PowerShell script that we're going to execute. If you notice here, we have sample usage of this script. It's very simple. blg to SQL.ps1, perfmon directory, and then specify the location for that given server, and then the server name. Makes it really easy to go script out for multiple servers down the road. If you scroll down here, there are a handful of connection and target information details that you can pre-specify so you don't have to type it in each time. For this one, I've pre-specified the Perfmon directory at the sample directory that I have on my desktop on this workstation. I have the server name of the machine that I'm profiling, and then a connection string here that's pointing over to a different machine with the initial catalog Perfmon import. We do have specified the application name, so we know which application is actually doing the work. If you scroll down in here, you'll find that what it does is it checks to make sure the target directory that you specified is present. And then it goes through and does a check to make sure that we can connect to the SQL Server. If so, then we're good. Let's go ahead, and what it does is it unpacks all the cab files, which are kind of Microsoft and Perfmon's version of a zip file. It's just not quite as handy. It converts those, it extracts them, and then converts them to a tab-separated value format, TSV. The reason for this is a traditional CSV might actually break because there's a handful of the Perfmon counters themselves where the names contain a comma, and that actually breaks our standard. So once it's done exporting those back to a CSV name, but a TSV format right here, then it actually does a SQL Server bulk import directly into our target table. And you can see we're mapping the columns. I actually have a batch size here equal to what column store indexes are really preferring on inserts. We map our columns, and then for every record, we perform our insert, and then it cleans up afterwards. Scroll back up to the top here, and let's run this. Right now, you'll notice I have a folder on the file system here, Perfmon Data, and each one of these corresponds to a day's worth of Perfmon data in a folder, and this is what you're going to see on a normal output folder on a given server. So if we just double click into one, you'll notice I have the BLG file right here. I have the CSV file, or really it's a TSV file because I've run and tested this a few times, but that won't be there by normal. And then a report, and this is automatically created by Perfmon. So what this script is really going to do is it's going to iterate through each one of these, load the data into a database, and away we go. So if we hit run, it goes through and converts everything from BLGs to TSVs with a CSV name. And while this is running, we can actually go over to SQL Server, and I'm using Azure Data Studio for this one, and we can just do a count, and we can watch the information start to trickle in. Our import has completed. You'll notice we're back down to a command prompt here, and it looks like we imported a lot of data, but let's figure out exactly how much. Here's Azure Data Studio. You can use this or SQL Server Management Studio, whatever your method to connect into your SQL servers to start to run some diagnostic queries here. Okay, first of all, let's confirm how much data we actually imported. So if we look at our Perfmon import table, you can see this Perfmon data set contained 36 million data points. Not too shabby. If we take a look at the information that it imported, you can see we have an ID value, server name, date, and time stamp down to every 30 seconds that we collected data. And then our counter set by process, processor, network adapter, things like that. Counter name, our instance name, and then our value. If we want to look at the entire time frame that we imported on this batch, because there was nothing else in this database, you can see here this was from April the 22nd to May the 6th. So it's a little over 2 weeks. So 30 million data points for that sounds like a lot, but it's actually pretty normal. This is at the point where any utility that you like Power BI, T-SQL, Excel, whatever you want to use, you can now get to this raw data to do whatever you want with for any sort of analytics that you care about. Now, out on GitHub, I do have a couple of sample scripts out there to give you an idea of what you can do. I'll show you a few of those right now. So first of all, I want to see the counters that are actually available to us in the system. So this query right here will give you all counters for this particular server. Counter set, counter instance. So memory available, M bytes, there's no instances for this one. Or physical disk, average disk bytes per read, things like that. Pretty handy. Now we have a sense for what are we actually working with here. The next query will go and grab a certain counter. In this case, I have it defined up here. This way you can do this as a rolling drop down in your reporting tool, however you want to do it. So you specify the counter set and counter, and then it goes through and it's going to grab us every one of those values. So you can see server name, date and timestamp, and this is CPU consumption by CPU core. In this case, this was a 16-core SQL server. CPU core numbers 0 to 15. Here's our counter value. Once we get past the first seed, you can see we've got some activity in there. Not too bad. It gives us the raw data, and now we can do something with it. If we want to do a little bit more advanced, we can actually do the same thing. So same counter. I want to see the average counter. Now I can run it like this. So you can see for every time sample that we now have our average counter value across all cores. The tough part with this is that it doesn't always do it justice. What if, let's say this on the 16-core SQL Server, 2 CPUs were going berserk and the rest were functionally idle? That can happen. With that information, what we end up getting is a skew, or we kind of average out the meaning of the data. In this case, we have a good solid number here. It doesn't tell us what those individual cores were doing. The next query here is designed to fix this. What it does is it's going to give us all of the instances for a given counter and then put them in the order of which we care about. In this case, it's CPUs, so they're in the order of the CPUs. We have to do a little bit of work here to get them into order, and we're actually going to be building a dynamic pivot table inside SQL Server to do this. But with this information comes a lot of power. Check this out. So I'm running this, and now you can actually see the date and timestamp, and now CPU 0, CPU 1, CPU 2. And we have our individual metrics all laid out right here. Pretty darn handy, because now here's our analytics, and now we can do something about this. We can do something with it. And it's in a nice, easy to consume format that dynamically adjusts, because not all of your same servers are going to have the same CPU count. Awesome. Now you know how to get to the data. It's in a raw format, and we can do something about it. Now you can schedule this to run every night. You can adjust Perfmon to just, start to compress after a given day, and you can turn around and import this nightly. And now you can start to build a data warehouse of your performance information. And that is absolutely critical to figuring out not just what happened yesterday when there was a problem, but day by day trends that really do matter depending on what's going on in your environment. Maybe license management, maybe you're interested in looking at the cloud and you want to figure out how big to size your cloud objects. All of these things you can do once you get the raw data. I just showed you how to set up Windows Perfmon data imports directly into a SQL Server for providing a foundation to analyze this data on an ongoing basis. Now that you've got the raw data, you're free to analyze this information in any way that you could possibly want with any analysis tools that you prefer. Make sure to let me know if you have any questions or concerns with this import process, and I'd love to hear your comments below. If this importer was useful to you and your business, please like this video. And for future notifications for new videos as we release them, please subscribe to this channel. Thank you for watching.